And let me pin this like this. Okay, so it's pinned. Mana gambar Kirchhoff saya tu? Tak ada. Okay. Okay, just to recap what we have learned so far. Am I muting you guys? Oh, tak. Okay, so just a little recap on what we have learned so far. So let me draw a diagram. This slide. So we have learned about Kirchhoff's, ada double H, is it? Yeah, there's a double H. Kirchhoff's law or rule. Okay, sama je. So there it's divided into two. The first one is junction rule. And the second one is loop rule. Okay, this is just a recap, okay? The junction rule tells you that something that is going into a junction, a current that is going into a junction becomes a positive, and a current that is going out of the junction becomes a negative I. Okay, so that is what it's saying. And then in the junction, the total summation of I should be equal to a 0, which means that if I have I1, I2, I3, the sum of these guys should be equal to 0. So this is what the junction rule says. And then we also have the loop rule. I think I need more space, so I'm going to shift this a little bit. Okay, so the loop rule, based on its name, we need to draw a loop. Okay, so we need to draw a loop. So we have a battery. This is our positive terminal. This is our negative terminal. And typically we also have a resistor or capacitor. Doesn't really matter actually, as long as it's a circuit. So I have a resistor over here. Why is it tebal? So I have a resistor over here. Okay, my resistor is ugly, but I think you understand what it is. And then I also, because it's a closed circuit, I will have current flowing through the resistor. So let's say the current flows from right to left. Okay. So based on the loop rule, the first thing that you need to do is draw your own loop. If they do not give you the loop, if they don't give you, if they don't put a loop inside your circuit, you need to draw it yourself. So the loop that you can draw can be either clockwise, this is clockwise, or anti-clockwise. Okay, anti-clockwise. Anti-clockwise tak apa. Yang jadi anti-vaccine sudah. Everyone should take their vaccines, okay? So anti-clockwise. So as I mentioned before, if I'm a clockwise, my signs will be different than if I were to draw an anti-clockwise. So the direction depends on your circuit, punya current flow, and also the battery terminal. So let's do that together. So if I am a clockwise loop, if I have a clockwise loop, I will see, if I extend this loop, I will see the positive side of the terminal first, the positive terminal of the battery first. So my V, the V for the battery will become positive. Let me write that here, it's positive V. And if I'm using the anti-clockwise loop, I will see the negative terminal first. So my battery becomes negative in my equation. The battery is still just the same battery, but in the equation, it becomes negative. As for the current, this is your current. Okay, this is your current, whatever current that is flowing. And if I'm going clockwise, I am actually traveling in the same direction as the current. So this becomes positive IR. Okay, this is R. Okay, so this becomes positive IR. And the opposite case for anti-clockwise, I'm moving this way, which is the opposite direction to the current. So it becomes negative IR. Okay, so basically that is it. And the summation of your voltages should be equal to a 0. Okay, and then from equation, oops, ada orang tak mute ke? Okay, so from your equation, you will need to rearrange your equation into I1, I2, I3, and V equals to V. This does not look nice. Okay, let's just go with a random equation. I'm sorry, but hari ni saya tak sihat sangat. I1, I2, sorry, it's minus I2 and minus I3 equals to a 0. And then for the circuit, let's bantai dulu. So we have 5 volt. Okay. So we have positive 5 volts. I'm using the clockwise loop. And then I will have a positive let's just say I is 2 MP. No, we are finding the I. Let's say this is I2 lah. This is I2. It's supposed to be positive and the R is equal to 200 ohms. Contoh So 200 ohms. This should be equal to a 0. Okay. So now I need to rearrange this into a matrix. Now I only have 2 equations, but supposedly you're supposed to have 3. Yeah? So you should rearrange it like this: I1, I2, I3, and then equals to V. Okay, so here I have, for my I1, there it's a 0, so it should be 0. And for my I2, it's 200, okay, positive 200. And I3 is missing from this equation, so it should be a 0. And if I were to equate this to V, this guy goes to the other side. So this becomes minus 5. So my equation becomes it becomes minus 5 over here. And for this equation, I1 is positive, positive 1. I2 is negative, negative 1. I3 is negative, negative 1. There's no voltages in the junction rule, so it is always equal to a 0. Okay? And assuming that we have another equation, blah, 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 something over here. Okay? So in your calculator, this will be your A, B, C, D values. Okay? You need to arrange your equations in this format before using the calculator. Of course, you can solve it manually, but you can double check using the calculator as well. Okay? Or you can do it, do the calculator and then check it manually. It doesn't matter. Okay? So that was your recap. What did I miss? I think we're good for now. Okay, so let's do an example. Oh, we talked about the divider, potential divider, and also about current divider. So potential divider is really simple in the sense that it's just a ratio. If you want to know what is the voltage over here, you need to know what is your R on that, you need to know what the resistance is. So let's say you want to find out what is V1 at resistor 1. So basically you are saying, okay, V1 over V total equals to R1 over R total. V should be related to R1. If this guy is R2, but you want to find, if you want to find if you want to find V1, but you put in R2, then it doesn't work. The ratio should be, if V is over here, then the R should be referring to the same V, okay? So V1 over V total equals to R1 over R total. What is your V total? Your V total is always your battery. Okay, this is for a circuit looking like this. For the DCs, for the circuit looking like this guy, you basically you can't use the potential divider equation, because here you have 2 batteries and we don't know the distribution of the voltages across these resistors. However, for circuits like this guy, where you only have a battery and the battery is divided divided among resistors, then you can use the potential divider. Do you need to memorize this equation? No, not really. It's just a ratio. You can use the Kirchhoff's rule, and you will still find the same answer. You still get the same answer. So memorizing this is not necessary. Okay, it's just like pemahaman lah sebenarnya. And then you also have current divider. Macam mana saya nak moderate webinar ni, mampus. Okay, so you have the current divider. So if you want to know what is the current through Rx, what you need to do is not like the voltage divider. The voltage divider kita cakap pasal ratio, right? For, I mean, the ratio of that macam mana cakap? We are referring to the same place. So if I want to find V1, I will need to input R1. This is potential divider. Whereas for current divider, you want to find Ix. But what you are inputting in your resistor is anything that is not Rx. So anything that is not Rx is R1, R2, R3. So this is your RT, okay? Over Rx over plus RT. I forgot to check back on this one. Times with the IT. IT is your I total. Ix is what you're trying to find. Again, the ratio is whatever that is not Rx. Okay, so it's RT over total. Okay, nanti kita boleh try kot in an example. Okay, so this is the first example. It's in your web assign. I think the problem is quite hard, so we are doing it together. So using Kirchhoff's rule, find the following. I'm recording, right? Okay. Find the following. So epsilon 1 or battery number 1 is 70.8. So this guy is 70.8 volts. And battery number 2 is 61, right? And battery number 3 is 79.2 volt. Okay, so that's your battery. What about the current? Okay, so in a conventional circuit, sorry, conventional current. Okay, I don't know if I mentioned this to you guys or not. Conventional current flows from positive terminal towards the negative. Okay, so I think this should be in your book. I'm not sure. Conventional current flow ni macam is a type of definition, so you could be questioned on it. It's a definition. So in your direct current, conventional current flow, ada. Okay, tak ada. That's weird. Okay, so conventional current flows, I'm telling it to you guys, conventional current flow flows from the positive terminal of the battery to the negative. So here, your current will always flow, ni conventional current. Your current flows from here, positive. Your current flows from here, positive. Your current flows from here, positive. The word conventional is necessary because, like I said to you before, your current, you can change your direction of current. You can make it like this, you can make it like this. It doesn't really matter. But for conventional current flow, maksudnya standard lah. Conventional current flow flows from the positive terminal of the battery. Okay, so that is a definition that I think is quite important. Okay, so moving on, I want to label my current based on the conventional current flow. So let's see. I want to put this guy as my junction. I can also make F as my junction. It doesn't really matter. As long as there's a junction, you can make it your junction. Okay, so I want to make my junction at C. Okay, so let's focus on that. So my I flows here, I1. This guy is I2. And this guy is I3. That's the first step for your junction rule. This one. Okay, so saya nak ikut skema jawapan saya lah. Saya dah buat dah soalan ni. So I labeled I1 like this. So this is I1. This is I2. Okay, and this is I3. Like I said before, you can follow the conventional current flow, or you can just make your current direction as you like, and then your answer will tell you if you got the direction correct or not. Okay, so I1 goes into the junction, I3 goes into the junction, I2 goes out of the junction. So my junction rule, punya equation is so junction rule. Okay, so junction rule is plus I1 plus it's minus I2. Oopsie. Kalau ada saya salah buat, bagi tahu and then plus I3 equals to a 0. Okay, so this is your junction rule. It should always equal to a 0. Kenapa Louis conteng saya punya screen? Okay, next. And then the loop rule. The loop rule, the first thing that we need to do is draw your loop. Okay, so let's use a color that is more visible. So I want to do clockwise. Did I do clockwise? Yep, I did clockwise. So this is my clockwise loop. This is loop number 1. This is loop number 2. I have a feeling that this is not going to, I don't have enough space. So let me selesaikan dulu. Does anyone have any questions?
Sekejap. Enggak. Dah buka. Dah. Doktor.
Kenapa Fairuz?
Cakap Syah. Sabar, kau senyap sikit. Okay. I have a question.
Okay.
About the I2. Is it because of the second battery? Bukan ke macam yang arus tu dia pergi ke dalam juga sebab kan positif terminal kan yang tengah-tengah kan?
Betul. Like I said, conventional current flow flows from positive terminal. Betul. What Fairuz said is correct. But saya dah cakap sebelum ni, your current you can make it any direction as you want. But if you want to follow the conventional flow, the conventional current flow, then you can make it like this. Boleh je, sama je. Boleh juga. So maybe someone else can try to make I1, I3, I2 into the junction and then compare their answers with me. Okay? But I will be doing I2 going out because boleh. Sebenarnya boleh. Faham tak? Okay, I'm going to repeat myself. So conventional current flow daripada positive terminal macam ni. Yang sepatutnya macam ni lah. But I told you sebenarnya I can draw my current any direction that I want. So let's say I choose this junction, I can say okay, I want I want all currents to flow out. I can write it like this. Boleh. Nanti when I get my answers, if my answer is positive and my I2 is negative, this is the answer, jawapan yang bila kita klik akhir nanti. My I3 is negative. Positive meaning my I1 direction is correct. I2 negative meaning it's supposed to be this way. My I3 is negative, okay, maksudnya I3 sepatutnya macam ni. Terbalik daripada direction yang saya letak in the beginning. Okay, so your answer will tell you if your direction is correct. So the conventional current flow ni is just a definition. You don't have to follow it. It's just a definition. You can make it against the conventional current flow. Boleh. Nanti jawapan dia akan the answer will tell you lah what is the correct direction. Nanti kita akan tengok. Okay. So I2, I want to make it going out of the junction. Okay. This is an example that I can make it the other way. I mean, I can change the direction. Okay, I don't have to follow the conventional current flow. That is my point here. Okay, so my junction rule is like this based on the current that I drew. I am the one drawing the current flow. If your circuit already has the current flow drawn, you should follow the direction that yang diorang dah bagilah. Kat sini diorang tak bagi, so saya lukis sendiri and suka hati saya nak letak macam mana. But if they ask you what is the conventional current flow, it is from the positive terminal. That's the definition. Okay. Okay. So now let's go on
Doctor,
to. Yep.
I have a question. If the battery terminal is upside down, which means that macam contoh dekat nombor 2 tu, positif dia yang besar kat bawah, negatif dia kat atas. Still arrow dia ikut suka kita juga ke?
Ikut suka hati kita.
Oh, okay.
Okay. The only thing that you need to remember is the definition of conventional current flow is from positive. Ni conventional, maksudnya macam standard. Tu je. Okay.
Thank you, Doctor.
Okay, so I'm going to rephrase what Umar said. Umar said, what if our battery is like this? Can my I2 still flow out of the junction? Yes, the answer is yes. Based on the conventional current flow, it should be flowing like this, right? And it follows the conventional current flow, which is okay. If you want to make it the other way, pun boleh. Doesn't really matter. Your answer will tell you if your direction is correct or not. Okay? So let's move on to the loop rule. Our first loop is L1. This is the guy. So my guy flows from here to here, blah, blah, blah. Okay, so the first thing that I see is a negative terminal of this battery. So I'm going to start with negative 70.8 volts. And then I'm going to flow. And then I see this positive battery terminal, which is volt battery number 2. Battery number 2 is 61. So it's a positive 61. Right? And then, sekejap saya padam ni bateri Umar ni. Bateri saya kat sini je. Okay, and then I continue my loop and then I see R2. R2, right? R2 has I2 current flowing through it, okay, based on this guy. Based on the current that I drew, I2 is flowing in R2 and my loop is in the same direction as I2, right? So it's a positive. So that becomes positive, sorry, positive I2 R2. Okay, R2 is given is 3 kilo ohm. Nanti kita akan masukkan values tu kemudian. Okay, so and then I continue my loop, blah, 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 masuk sini. Okay, so now I see 2 kilo ohm resistor and I need to know what is the current flow. Okay, so I'm going to ask you guys, is the current flowing in my R1, is it I1 or is it I2? Is it I1 or is it I2? Anyone wants to try? It's okay. It's okay to be wrong. We are all learning. No one wants to try? Okay. So the answer is, no one wants to try? Kenapa takut je? Okay, the answer is I1. Okay, I'm going to repeat myself. The question is, what current flows through resistor number 1? Is it I2 or is it I1? So I1 is this way, right? And I2 is this way. Okay. So if I were to redraw this circuit, tapi tak payah pun, korang bayangkan je lah. Macam tu. Okay, I can say that this is the branch that I1 flows in. This is the branch that I2 flows in. Okay. So this guy sebenarnya kat sini. Dia letak kat situ supaya kita confuse. Okay, so basically R1, the current that flows through R1 is I1. Okay, is everyone clear on that? Okay ke? Confused ke? Okay, so I'm going to continue. So in R1, our current is I1. So it's this way. Okay, because when I extend it, it's this way. So it is a positive because our loop is in the same direction as our I. So this becomes positive I1 R1. Okay, equals to 0. I already completed my loop. Okay, so and then number 2 loop. Yep. Yeah.
Oh, it's okay, it's okay. Okay.
Okay. Okay, Umar. Kalau ada soalan, tanya. So loop number 2. Okay, let's move on to loop number 2. The first thing that I'm going to start here, okay? My loop flows from here to here and so on. So the first thing that I see over here is negative epsilon 2 or negative battery terminal. So it is negative 61 volts. And then I continue my loop and I see I3 flowing in R3, but it is in the opposite direction as my loop. So it is a minus I3 R3. And then I continue my loop. I see the positive side of the battery for battery number 3. So that is positive 79.2. And then I continue my loop and I see this guy over here. This guy has I2 flowing inside and it is in the opposite direction as my loop. So it's a negative I2 R2. Okay. And this I have completed my loop, so this should be equal to a 0. Okay, let me check. Negative I2 R2, negative V2, negative I3 R3, positive V3. Okay, betul. Okay, so this is my first loop. Second loop, this is the junction rule. So if I were to rearrange it into a matrix, right? To use my calculator, you can also use a manual way to calculate as long as you get the right answer. Okay, so now let's rearrange it into a matrix form. Okay, so matrix form I1, I2, I3, and V on the other side. So this is equal. So this is my matrix. This should be I1, I2, I3. Tapi korang boleh abaikan ni. Saya tahu korang dah belajar ke belum matrix dalam apa nama dia? Math. So this is your V. Okay, rupa dia macam ni lah sepatutnya. Saya macam I butchered the math. Okay, so so I1 for the first equation is positive 1. I2 is negative 1. I3 is positive 1. Okay, so that's our first equation. It's equal to a 0. So I put the 0 over here. Okay, and second equation. I have I1, R1. What is R1 here? R1 is 2 kilo ohm. So that is a 2000. Okay, 2000. And then for the for loop number 1, I have I2, R2. So my I2 has R2. What is the value of R2? It's 3000 ohm. It's a positive. And then for I3, it's missing from this equation, so it's just a 0. And for my volt, I need to transfer whatever that is not related to I1 and I2 and I3 and move it to the other side of the equation. So this is, already have it here, minus 61 plus 70.8. Alamak. Minus 61 plus 70.8 is it's 9.8. Jawapan saya tukar sikit. 9.8, okay. Where should I put it? Let's see here. 9.8 volts. 2000, 3000. Okay. And then for loop number 2, we have I1 is missing, so it's a 0. I2 is minus R2, minus R2. So R2 is 3000, so it's a minus 3000 over here. And I3 is also a minus I3 R3. R3 value is 4000. So it's a minus 4000. Okay. And then the voltage should be moved to the other side, which is positive 61 minus 79.2. So that should give me, that's weird, minus 61. Minus positive, positive 61 minus 79.2. So it's minus 18.2. The second equation, should it be negative or positive? Negative, positive. Okay, it should be positive. So this guy is a positive, this guy is a negative. Okay, now I can use my calculator. Equation unknown is 3, A1 is 1. What is B1? B1 is minus 1. What is C1? C1 is positive 1. D1 is 0. And then A2 is 2000, 3000, B2, C2 is 0. And then the D2 is positive 9.8. And then for A3, it's a 0, minus 3000 for B2, and then minus 4000 for C2. And for D3, sorry, saya cakap 2 and tadi, it should be 3. And for D3 is minus 18.2. I hope I got it right. Just salah je. Yeah. 2.66. 4 point. I got it wrong. Our equation is wrong. This is why I wanted to use the same example as my apa nama ni, schema jawapan ni. Okay, so we did something wrong. Can anyone tell me where I got it wrong? So this is 70.8. Betul. 61. Where's 61? 61 is battery number 2. And then 79.2. 78, 70.8, 61, 79.2. This guy is 61. Okay, so that is right. Equation lain semua betul patutnya. What is wrong here? 70.2. Okay, let me check the equation. So equation junction rule, I1 goes into, I2 goes out, I3 goes into, equals to 0. 1 minus 1, positive 1 equals to 0. Okay, the first one is correct. Loop number 2. Okay, loop number 1. Okay, loop number 1, I come across E epsilon 1, which is 70.8, negative. And then I come across positive terminal of epsilon 2, 61. So positive 61, correct. And then, oh, I forgot to write this. I1, I2, and I3. Okay, and then I2 times R2, positive. And then this guy, I1, R1, positive. Okay. And then for loop number 2, it's minus 61. Epsilon 2 is minus.
Doktor.
Epsilon 2 is minus. Yep.
Doktor.
Yep.
Tadi kita orang kan dapat.
Okay, matrix.
Doktor dapat je.
Kat kalkulator.
Sebenarnya saya salah tekan calculator lah. Aduh. Okay. Okay, so we got the right answer lah. Okay. So what was the answer? Can you tell me yang apa yang dalam calculator tu? So I1, X is
5.38 times 10 to the power negative 4.
okay, and then Y
2.91 times 10 to the power negative 3.
okay, and Z
And 2.37 times 10 to the power of negative 3.
okay, thank you. Nak mango kan tu?
Yeah,
Okay.
yes.
Thank you. So X, you will get your answer in X, Y, and Z. So X will refer to I1. This is your X, this is your Y, and this is your Z. Okay, it depends on the order that you put in your equation. So if I wanted to flip this into I2, I3, I1, boleh, but I2 will become X, I3 will become Y, I1 will become Z. So nak senang, just maintain as I1, I2, I3. So you know that X, Y, Z refers to I1, I2, and I3. Okay, so it's just math here. Okay, so here the answer is 0.538 milliampere. Milli times 10 to the times 10 to the power of minus 3. So this one, if I rearrange it to become minus 3 semuanya, 0.538 times 10 to the minus 3, which is the same. Okay, the rest is the same. And then the second question is the potential difference between points C and F. Between point C and F, what is the potential difference? Let me duplicate this question. Excuse me. So kita padam ni dulu. Let's keep our answer. We already have our answer here. Okay, so it's asking the potential difference between point C and F. Now here you can approach it in two ways. First, you can say it's the potential difference from here to here, or the potential difference from here to here. Pun boleh, it's still C to F. C, D, E, F. C, F, boleh. So either way, you will get the same answer, but let's go with CF down here. So your I2 is flowing down and I2 is a positive, which means that our direction of current is correct. So I2 is flowing down and we have battery, positive battery here, a volt 61. And then we have I2 flowing in R2. So whatever the voltage on here will be the potential difference between point C and F. So here between C and F, the voltage I see, the first one is V2, which is 61 volts. And then I will plus it with I2 R2. I2 R2. So this is the equation. V2 is 61 plus I2 is 2.91 milliamp times with R2. R2 is 3000. So this 3000 cancels out the milli. So 2.91 times 3 lah basically. 2.91 times 3 plus with 61, you will get 69.73 what is it, volts. Okay, betul. Okay, what if I what if I wanted to see from this angle? Okay, what if I wanted to see it from that angle? What the potential difference? C, D, E, F. Okay, let's try it. I should be getting the same answer, but how should I do it, right? Okay, so point C, D, E, F, or CF je lah basically, but I will specify it as C, D, E, F so that you know which loop that I'm referring to. So this guy, we are going to see what is around here from C to F. So the first thing that I see is I3 flowing in the opposite direction as my direction. My direction is from C to F. So this is my direction, but I3 is in the opposite direction, right? So it's minus I3 R3. Okay, sama je, asalkan sama direction, positive. Kalau opposite direction, negative. And then I will see positive side of the battery, which is a positive. This is battery number 3. So I will add 79.2. And then that's it, right? So I3 minus I3 is 2.37 milliampere times with R3. R3 is 4000 kilo ohm, sorry, 4k ohm. So K cancels out with milli. K is 1000, milli is 1 over 1000. So it cancels out, plus 79.2. So 79.2 minus with 2.37 times 4. So I get 69.72 volt. Sama je. Okay, lebih kurang lah jawapan dia. So here, if you want to find what is the potential difference from point C to F, so you start your flow from C to F. Your flow starts like this, right? You see the positive terminal of the battery, so it's a positive. The current flowing in the same direction, so it's a positive. If you are using this flow from here to here, you see the positive terminal of the battery is a positive. but your current was flowing in the other direction, so it's a negative. Okay, so this is how you calculate for the potential difference from a point, from one point to another. Quite important, eh? So the magnitude of potential difference, we got it. The point at a higher potential should be C. Okay, because it's a positive, we got our answer as positive, right? So from C to F, C will have the positive potential and F will have the negative potential or the lower potential. Okay, because our flow starts from there and our answer is positive. Okay, I'm going to repeat myself. The magnitude of potential difference, the potential difference at point C and F, and the magnitude of potential difference at higher potential. So the question, this is the question. The question is this one. Point at higher potential. Okay, I'm going to repeat myself. The question is asking you, what is the point at higher potential? Is it C or is it F? The answer is C because your answer is a positive. So your C should be the positive terminal, should be the positive potential difference. Should be the positive potential. Okay. If your answer is negative, then C will be the point at lower potential. So it depends on your answer. Okay. Sorry saya macam tak pandai cakap pula hari ni. So positive answer. So the point that you start with is the positive, is the higher potential. If your answer is negative, the point that you start with is your lower potential. Okay. Next example. Lamanya kita pakai masa. Okay, next one. Consider the circuit shown in the figure below. Assume R1 13.5 and R2 5.5. So it's asking the potential difference between point A and B. So this is the point. Or you can say it's from here to here. Pun boleh. Okay, so let's use the loop rule. Do we have to use the loop rule? I can simplify this diagram to become. Saya nak try lagi soalan ni, saya tak tahu. So this one is R1. And since this guy is in parallel with this guy and in parallel with these two guys, I want to simplify it. Okay, so R2 plus 20. R2 is 5.5. So this becomes 25.5 ohms. Okay, can someone please check my work and see if I'm doing things correctly or not? Tolong check saya punya kerja juga. So this is the first time that I'm doing it. So R2 is 5.5, this is 20, so we get 20.5 over here as our R equivalent. R equivalent of R2 and 20. So R2, oh okay, value sama. R2 slash 20. So that is 25.5. R2 is 5.5. R1 is 13.5. These guys are in parallel. How do I know they are in parallel? Use the trick that I told you. Put a dot. If they are connected by the same two dots, they are in parallel. So R1 is connected to this dot and this dot, point A and point B. Oh, kita tak boleh pakai AB. And R2 is connected by these two dots and R2 slash 20 is also connected by the same dots. So we can say that they are in parallel. However, R1 is not in parallel because it is only connected with the downward dot, but not the top dot. So it's not in parallel. So now I'm going to simplify these three. Okay, so 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R220, which is 25.5. So now I'm going to substitute. So R1 is 13.5, R2 is 5.5, R2 slash 20 is 25.5. So R equivalent is, can someone please check what's the answer while I redraw this? What's the answer? No one is trying?
3.39, Doctor.
Berapa?
3.39.
3.39 volts. Okay. Volt tak dah.
Ohm Doktor.
Thank you. Okay, so that is our R equivalent. And then we want to know what is the I flowing through this whole circuit because we want to find out what is the potential difference, right? Okay, so here I have two R's and I have a single battery. Now our circuit is simple and I can just use V equals to IR, right? So my V is 25. I want to find out what is the I, and the R, the total R for this circuit is R1 plus R equivalent. So R1 is 13.5 plus with R equivalent of 3.39. Okay, so it's 16.89. Okay, and then my I becomes 25 divided by answer is 1.48. Okay, 1.48 volts. Ampere. Okay, so now I want to find out what is the potential difference between point A and point B. So I can look at it in two ways. I can say I want to find out from here to here, or I can find it out through here to here. So let's do it in both ways. So the first one, whoopsie, where is my, so I learned. So this is the first one, second one. Let's call this loop 1, this guy as loop 2. It's not actually loop, line 1 and line 2. Okay, so line 1, we are looking from A. Sorry, I forgot to mention the I flows from here. Okay, when we use the V equals to IR, it should follow the conventional current flow. So our I flows from the positive to the negative. So this is our I, okay, 1.48. I'm going to repeat myself. When we use the equation V equals to IR for a simplified circuit, our V is from the battery and our R, we use the total R from the circuit. So our current should follow the conventional current flow, okay? So that is a point that you need to remember. So L1, VAB for number 1. Okay, I'm looking at from this angle. Our I is in the opposite direction. Macam mana? Kenapa jawapan dia terbalik ni? Kejap. If my I is flowing this way, it should be negative. From point A to point B. Okay, tak apa, kita cuba dulu. So minus minus I 1.48 times with what's the R that we are looking at? R equivalent is 3.39. Okay. So 1.48 times 3.39 should give me 4.88. Sorry, 3.39 times with 1.48 should give me 5. But my 5 is a negative. I need to know why this is. Okay, tak apa. Find the current in the 20 ohm resistor. 20 ohm resistor is over here. Okay, so 20 ohm resistor is over here. I want to know what is the current flowing in here. Okay, so remember, if we have an I, this is our I total that should flow in the whole circuit. This I meets a junction, it should be divided into several, let's call this I1, I2, I3, and I4. For parallel circuit, the I's is not the same, but the V's are the same. The V's are the same, but the I is not the same, right? So we already know what is the V from point A to point B, which is 5. Let's follow the soalan dulu. Soalan punya jawapan. Nanti saya akan tengok balik kenapa dia negatif. So let's say we know that from point A to point B is 5 volts. This guy should be 5 volt as well. This guy should be 5 volt as well. right? So if I wanted to know what is the current flowing through the 20 ohm resistor, I should divide 5 volt by R2 plus 20, which is 25.5. 5 volt, okay, 5 volt divided by, sorry, equals to I times 20 plus R2, which is 5.5. Kita dah buat soalan yang similar before this. I told you if we are trying to find the current flowing through this whole line, we need to find out what is the voltage for the whole line and what is the resistance for the whole line. Bukan dekat resistor 20 sahaja, but the total resistance in that line. So for this whole line, it's 5 volt. For this whole line, the resistance is 25.5. So baru saya boleh cari I. So 5 divided by 25.5, the answer is 0.197. Okay. Cuma saya tak tahu kenapa dia negatif ataupun dia positif. Terbalik ni. Nanti saya akan check balik on this. But other than that, I think we are done with class. And I need to check back on that. Okay, any question?
Doktor, yang VAB 1 tu doktor buat yang guna L1 ke doktor?
Nak buat pakai L2 boleh? Dan kita buat pakai L2. So VAB line number 2, what is line number 2 from here to here? Kan? Okay, so VAB, alamak tak nampak sangat. Let me write it over here. VAB number 2 equals to, okay, so my line, I see R1 and I said I1 flows in the same direction. So my I1, this is I1, R1, positive. Sebab dia flow in the same direction as my line. And then this guy, I see the negative terminal, so it's a minus 25. So I already know what is my I1, right? I1 is 1.48 times with R1. Tertutup pula. I need space. Sekejap 1.48 and then R1 is berapa tadi? 13.5. This is a positive, minus 25. So let's see. 1.48 times 13.5 lepas tu minus 25. I will get minus 5.02, which is approximately the same. Okay. Jawapan dia macam lari sikit, but it's okay. Asalkan you show the working steps and it makes sense, so you should be fine. If you use line 1 ke, line sini ke, doesn't matter. You will get the same answer, approximately the same answer. The only thing that I don't know what's going on here is why it's not a negative. Nanti saya check back on this and I will inform through WhatsApp. Okay, so is that okay? So do I need to do the current flow through R20, 20 ohm again? Sama je kan? It's still 5 volts. Negative sign tu je yang saya tak tahu. Nanti saya bagi tahu balik. Any other questions? Is everyone okay? Everyone doing good in college? Panas kan sekarang? Kesian korang. Harap ada kipas lah. Kipas extra. So everyone's just silent today.
Panas.
Ah,
Panas sampai malam kena macam
kan?
kena saya ada macam baldi air kat bilik.
Oh,
Untuk saya letak air kat badan sebab panas sangat malam.
kalau korang ada spray tu, spray badan pakai air. Dia boleh sejuk sikit. So hot. Okay, take care everyone. Kalau demam, jangan lupa makan ubat. Other than that, take care of your SOP. Do not forget to eat. I will see you masa test lah kan? Masa test. So we have 1 more week left. Next week kita akan buat revision insyaAllah. Okay, so take care. Bye everyone. Have a great weekend.
Thank you, Doctor.
Welcome.
Thank you, Doktor.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you,
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Bye-bye.
Thank you, Doctor.
Bye.